The universe is supposed to follow the rules, right? We have laws of physics that pretty much govern everything. But every so often, astronomers find something that, well, it seems to be breaking them. Our first rule breaker? It's a planet that, by all accounts, just shouldn't exist.
Okay, take a look at this number. 0.059 grams per cubic centimeter. That's a density. So the big question is, the density of what? I mean, it's way too low for rock, or even water. What in the cosmos could possibly be this flimsy?
All right, for a little perspective, on one side you've got Jupiter, a pretty dense ball of gas. Then there's Saturn, which is famously so light it could float in water. But our mystery number? It's not even close to them. It is actually much, much closer to the density of cotton candy. Yep, you heard me right.
So let's meet WASP 193b. It's an exoplanet so light and fluffy that it's been nicknamed the cotton candy planet. Get this, it is huge, almost 1.5 times bigger than Jupiter, but it has less mass than Saturn. This thing is what we call a superpuff, and it completely throws our standard models of planet formation right out the window. It is a perfect, and I mean perfect, example of a cosmic rule breaker.
But you don't have to look hundreds of light years away to find these kinds of cosmic puzzles. Turns out, we have a huge one right here, hiding in the dark, cold edges of our very own solar system. It's like a celestial crime scene, and the clues have been piling up for years. So this story really started to unfold back in 2004. Astronomers found Sedna, this little dwarf planet on a wild, super stretched out orbit that just made no sense. It was way too far out for Neptune's gravity to be messing with it. Fast forward a decade, another object with a similar weird orbit pops up. And then, in 2016, astronomers Konstantin Batygin and Mike Brown had a breakthrough. They realized this wasn't just a couple of weird coincidences. A whole group of these distant objects were all moving in a strangely coordinated way.
And this quote right here, it just nails the core of the problem. If there's nothing else out there, the paths of these distant, icy bodies should be all over the place, totally random. But they're not. Okay, so this is what the scene should look like. Imagine looking down on our solar system from above. The long, oval orbits of all these faraway objects, they should be pointing in every possible direction, completely scattered like the spokes on a bicycle wheel, no pattern whatsoever. That's the baseline. That's what we expect to see.
But this is what we actually see. Instead of being random, a handful of the most distant objects have orbits that are all tilted in the same direction and bunched together. It's almost as if some unseen gravitational force is hurting them, keeping them penned in one corner of the sky. The odds of this happening just by chance? Tiny, less than 1%.
So, this strange clustering, that's our evidence. And for every crime scene, you need a suspect. So let me introduce you to the leading theory, the prime suspect in our little cosmic detective story.
This is the Planet 9 hypothesis. It was proposed by Batygin and Brown, and it's a really elegant solution. The reason all these small objects are clustered together is because they're being gravitationally corralled by a single, huge, undiscovered planet that's orbiting way, way out there beyond Neptune.
And this isn't just some vague guess either. Their computer models give us a really detailed profile of our culprit. We're talking about a super-Earth, somewhere between 5 and 15 times the mass of our planet. Its orbit would be massively stretched out, taking it hundreds of times farther from the Sun than we are. And a planet with exactly these properties would, over billions of years, naturally sculpt the outer solar system into the exact shape we see today. But, science is never about locking on to just one suspect. A good detective and a good scientist always considers the alternatives. What if the evidence is pointing to something else entirely?
And that is the big question that's driving this whole debate right now. The clustering is real, we know that. But is a single planet the only possible explanation for it? So let's run through the other culprits on the table. First up, observational bias. Is it possible we've just gotten unlucky and only looked at the part of the sky where these objects happen to be? Some surveys hint at this, but deeper analyses still show the clustering is statistically real. Okay, next idea. Could a massive disk of smaller, icy bodies be doing the job with its combined gravity? It's a plausible thought, but we just haven't seen anywhere near enough stuff out there to make it work. And then there's the really wild one. Maybe our understanding of gravity itself is wrong. A theory called MOND suggests these orbits could be aligning with the galaxy's gravitational field, which is a fascinating idea, but it would mean rewriting some fundamental physics.
So where does all this leave us? Well, with a fantastic, unresolved cosmic case file. The evidence is on the table. We've got our prime suspect, and we have a lineup of alternative culprits. The verdict is very much still out on this one.
And you know, this whole saga is just a perfect illustration of the scientific process in action. It all starts with a weird observation that doesn't quite fit, that leads to a bold new hypothesis, then comes the really hard work. Testing, debating, gathering more data, and coming up with other ideas. And that final step, the search for definitive proof, that is happening right now as telescopes scan the skies night after night.
And honestly, this is the most important takeaway from the whole thing. The real prize isn't necessarily finding a ninth planet. It's the process of the hunt itself. That search forces us to build better telescopes, to develop smarter models, and to question our most basic assumptions about how solar systems even work. That's how science really moves forward. So, whether the final answer turns out to be a hidden planet, or a huge disk of ice, or even a brand new theory of gravity, the mystery leaves us with one absolutely thrilling question. What else is hiding out there in the dark, just waiting for us to find it?